Very good morning and welcome to all of you. I am Mr. Shashikant B. Gosavi, Assistant Professor, Department of Civil Engineering, Walchand Institute of Technology, Solapur, presenting an online educational resource on errors in global positioning system. The learning outcomes of this online educational resource are that at the end of the session, the learners will be able to identify major types of GPS errors affecting positional accuracy. The second learning outcome is the learner will be able to explain the causes of satellite related atmospheric and receiver related errors. The next learning outcome is the learner will be able to analyze the effect of dilution of position on GPS accuracy. And above all, the learner will be able to suggest methods to minimize errors in surveying practice. Let us start with the introduction of global positioning system errors. GPS provides positions with meter level accuracy, but errors occur due to several reasons. Few of them have been listed over here. The satellite factor is of course one of the most important factor which affects the error. It may have settings in the atomic clock or the ephemeris of satellite itself, which may be resulting into the errors related to this. The second variety of the errors which are likely to be there are atmospheric conditions. You know that in global positioning system, the signal travels from the respective satellite up to the user's instrument. During its journey, it has to pass through several atmospheric layers as well as conditions. These do affect onto the error into the user's handset. The other one is related to the receiver limitations. The receiver itself may have a lot of limitations because the hardware is there, clock inside the receiver is there. These may also be resulting into the error in GPS. The user geometry is equally important. The location of the user and its availability of satellites are also going to affect. Besides that, the nearby other buildings or trees or similar kind of the objects nearby the user might be influencing onto the error in global positioning system. You can see here what has happened. At the bottom you can see there is something true receiver position. So receiver is somewhere existing over here at this location. There is effect of several incorrect pseudo range ephemeris and positional dilution of precision happening due to its journey and geometry. So the respective signal will be ultimately ending up in giving a apparent position which is shown over here. So the four spheres which actually work on the principle of trilateration provide is the intersection at this particular circle, which is intersection of the four sphere surfaces or more than four sphere surfaces to precisely identify the position of the user. However, because of these particular errors, there can be this particular numerical error resulting into some other location indicated by the global positioning system. We have to identify the sources and try to eliminate or preferably avoid these particular errors. The first error type that we have seen previously was satellite error. You can see that there are three possibilities related to this. One is, as I said, there is atomic clock, and atomic clock itself may be having a error in its setting. Small deviations in satellite atomic clocks may result into something which we call as the clock error. Ephemeris error is the inaccuracies in predicted satellite position. You know that satellite keeps on transmitting a message in which its position is also encoded. However, this encoded position itself might have got certain errors, which ultimately will be read by the user's handset, and accordingly the positional inaccuracies or errors will result. Due to satellite, there is another important error. It is because of the shift in user position by several meters due to its impact. There is another important source of the error which is called as atmospheric errors. Ionospheric delays are likely to be there. All of you know that there are several layers around Earth, and ionospheric layer is someone which is closest one. The signal bends due to the charged particles, bends in the sense of refraction, and that will of course going to impact onto the error. So, due to this charged particles bending or frequency dependencies, ionospheric delay is likely to happen. And if the delay happens, obviously the time recorded into the user will be different, because of which error will be there in the positional coordinates. The other one is related to the atmospheric error, is tropospheric delay. This is showing a slowing of signals in lower atmosphere due to water vapor. If the signal slows down, again the delay is going to happen, and this delay is going to result into inaccuracies in time, which indirectly will be influencing onto the range calculations, and thus the respective error will be impacting. The other remaining atmospheric error is seasonal and time of day variations, which will be affecting the accuracy. So, due to summer, winter or rainy season, or early in the morning, midday or evening, or even at night, the slight errors are likely to happen onto the signal which is transmitted from the satellite up to the user. One of the other variety of the error is multipath error. Here, if the respective user is having his position nearby a building, or nearby a water surface, or nearby trees, chances are there that the ray which is coming from the satellite will actually get reflected from these nearby objects, and they will reach to the user's instrument. Obviously, this will be taking more time than what it should have obviously taken. So, this results into the inaccurate positioning of the user. This particular effect delays the signal reaching the receiver, and therefore inaccurate distance measurement will take place. The examples are urban canyon or near large structures. So, user should preferably choose a position which will be coming under least interference of these particular tall objects nearby the user's position. The other one of the important error is receiver error. The noise which is happening in receiver electronics, particularly because of warming up of the hardware, this is also going to cause the error into the output of the instrument. The quartz clock is normally used in any kind of the GPS handsets used by users, and these also have less accurate results as compared to atomic clock. So, users normally have the quartz clocks. So, clock error will be because of this also. Antenna design itself may have little bit inaccuracies. Poor reception of weak signals may result into this kind of the error, and this may impact onto the results by smaller results into the accuracy in terms of centimeter or meter level. Geometric dilution of position is another possibility. It is the error due to poor geometry of satellites related to the receiver. There are several types such as positional dilution of precision, horizontal dilution of position, and vertical dilution of precision. Depending upon the position, these are likely to result. Good geometry is expected, that means satellites which are available at a time of noting down the position should be widely spread. Preferably they should not be very close to each other at the center, and they are also not expected to be near the galaxy straight away. They should be in between, preferably within the range of 40 to 50 degrees at which you can find good geometry, and preferably at a different directions. Poor geometry is also because of clustered satellites. So, it should not be clustered, it should be well distributed. Of course, after discussing all these errors, obvious question is how to minimize these GPS errors. One of the options which have been devised scientifically is use differential GPS, where there can be two rovers, one of the rover at base station, other at different locations elsewhere, wherever we are interested in getting the positions. The other one is real-time kinematic and averaging multiple readings, and of course use of dual frequency receivers. In real-time kinematic, the respective base station directly communicates to the rover which is collecting new stations with the help of signal connectivity between them. The difference between DGPS and real-time kinematic is the DGPS can be post-processing and real-time kinematic includes the information about the errors directly communicated to the other instrument. This is the summary of what we learned today. Errors in GPS arise from satellite, atmosphere, receiver, multipath, as well as the geometry. Correction methods we have just now discussed, and understanding error is crucial for reliable geometrical applications. You can pause your video and read these questions. The answers to these questions are available as projected currently onto the screen. These are the references which I have used for preparation of this online educational resource. Thank you very much.